Have you ever looked at a cool web app and just wondered, how does that actually work? Not just the part you see and click, but everything happening behind the scenes? Well, today, we're going to do exactly that. We're tearing down a real-world project to see what makes it tick.
So our subject for today is a project from GitHub called To-Do App Phase 4. And yeah, on the surface, it's a to-do list app, but underneath, it's a whole lot more. It's a complete, secure application that can handle multiple users. We're basically going to take its technical blueprint and turn it into a story that makes sense.
Okay, before we dive in, let's get one big buzzword out of the way. Full stack. What does that even mean? It just means we're looking at the whole picture. From the database that holds your to-do items, to the server that does all the thinking, all the way to the shiny interface you see in your web browser. The whole shebang. All right, here's our game plan. We'll start with what the app actually does, its core functions. Then we'll get into the really important stuff, how it keeps your data safe. After that, we'll peek under the hood at the tech that powers it all. And finally, I'll show you how you could get this thing running for yourself.
First up, the back-end foundation. I want you to think of this as the engine room of a ship. You never see it as a passenger, but it's where all the power comes from. This is where the app's logic lives, where data gets sorted out, and where the heavy lifting happens.
Now, at the heart of pretty much any app that handles information, you've got these 4 basic actions. They go by the acronym CRUD. It stands for Create, Read, Update, and Delete. And trust me, these 4 things are the absolute bedrock of how we manage data online.
So how does that apply to our little to-do app? It's actually super simple. When you type in a new item like buy milk and hit enter, you're using Create. When you open the app and see your list, that's Read. Did you finish buying milk and check it off? That's an update. And when you're done with it and get rid of it, well, that's Delete. See? Simple, but it's everything.
So how does the app know what to do? Well, that's where this comes in. This table shows what are called API endpoints. Think of it like a restaurant menu for the app. The part of the app you see, the front end, can look at this menu and say, hey, I want to create a new task. So it sends a post request to that specific address, and the back end instantly knows, I need to create a new task. It's a perfect system. Okay, so we can make and manage tasks. That's great. But what if it's not just you using the app? You don't want some random person deleting your grocery list, right? This brings us to a super important topic: security. Let's see how this app solves that exact problem.
Just look at the difference here. Before you add any security, it's total chaos. It's like a public bulletin board where anyone can scribble on or tear off anyone else's notes. But once you add authentication, the app builds these invisible walls. Your to-do list becomes your to-do list, and nobody else can touch it.
So how does it build those walls? It uses something called a JSON Web Token, or JWT. The absolute best way to think about a JWT is like a secure digital keycard for a hotel room. When you log in, the app gives you a unique keycard. Every time you want to do something, like read your list, you flash that keycard and the app knows it's you and lets you into your own room.
And this whole keycard system is what makes all these cool security features possible. It means you have to prove who you are for every single action. It makes sure that your data is tied directly to you. It stops you from even accidentally trying to peek at someone else's data. And, just like a real hotel keycard, it eventually expires so it can't be used forever.
And what if you try to get in with the wrong keycard, or no keycard at all? The app has an answer for that. Think of these codes like a bouncer at a club. If you get a 401 unauthorized, the bouncer is saying, sorry, this ID is fake, or expired, you can't come in. If you get a 403 forbidden, the bouncer is saying, hey, your ID is real, but you're trying to get into the VIP section and you're not on the list.
All right, we've seen what the app does, and we've seen how it keeps things locked down. So now it's time to pop the hood and see what tools the developers actually used to build this thing.
So that back-end engine we talked about, it's built with Python, which is a super popular and powerful language. To actually build that menu of API endpoints we saw, it uses a framework called Fast API, which is known for being, well, fast. And to store all of your tasks and user info, it uses a really robust database called PostgreSQL.
But wait a second. If the backend is Python, why is TypeScript the biggest piece of this pie? That's the full stack part coming back. Remember? The Python code is the engine, but the TypeScript code, that's the dashboard, the steering wheel, the seats. It's the visual part of the app that you actually see and click on in your browser. You know, one of the coolest things about a project like this is that you can actually download it and run it yourself. It's not some secret, locked-away code. So in this last section, let's quickly walk through how you could get this to-do app up and running on your own machine.
It really boils down to 4 main steps. First, you clone the repository, which is just a fancy way of saying you copy all the project's code. Second, you install all the other tools it needs to work. Third, you tell it a few things, like how to connect to your database. And finally, you just run one command and boom, the application is live.
So really, when you zoom out, this project is way more than just a simple to-do app. It's a blueprint. It shows you the fundamental recipe for building almost any modern web application that needs to handle user accounts and keep their data safe. It's an amazing thing to learn from.
And that brings us to a final question to chew on. This app has a solid foundation, right? It handles tasks, it handles users, it's secure, but what's missing? If you were hired to work on this project tomorrow, what's the one big feature you think a to-do app needs that this one doesn't have yet? Something to think about.